In this video, we demonstrate one way to collect data for a live incident response based on the method from Real Digital Forensics, Computer Security and Incident Response, 6th edition. Our target computer runs Windows 10. You might want to perform a live response instead of a forensic investigation to diagnose a problem if the target system is too vital to shut down or too large to image, or if you believe the best evidence you need exists in memory. The goal of this response is to analyze volatile data, information that changes with time, or clues that disappear when the power turns off. Our priority is to record current activity and state and to collect data from memory before collecting anything else. By performing a live response instead of a cold forensic investigation, we make a trade-off. Interacting with the live system changes it, sacrificing some non-volatile forensic evidence to preserve some volatile data. We accept the risks of damaging the system or additional evidence, and the risk that a compromised kernel or system libraries might alter the data we collect. To perform this response, we use these tools: a forensics workstation with Netcat, a CD with the forensic software we will use, which comes from a copy of System32 executables from a clean system, and Microsoft sysinternals. Before anything else, we use Netcat to save data on our forensic workstation. On the forensic workstation, type nc-v-l-p with the port number, a file name. To redirect incoming data to a file, we will pipe the output of every command on the target to the IP address of the forensic workstation and this port. First, we list current network connections. We use our trusted copy of cmd.exe and type netstat-an. This shows all network connections and displays raw IP addresses. Current connections have a status of established, time wait, or close wait. A suspicious connection is one you cannot justify. Now we check open TCP and UDP ports. We can see these in the output from Netstat as listening connections. A suspicious open port is one that does not correspond to a Windows service or an intentionally running service. Notice that we send the output to our forensics workstation. For the sake of demonstration, we'll skip this in the rest of our examples, but don't forget it. For these open ports, we can find out which executables use them. We type netstat-abno to show all open ports and corresponding processes. We would be suspicious of any unusual results. Now we view the cache of the NetBIOS name table. This can help us identify addresses of hosts in logs, especially if the name table has been poisoned. We use the command nbtstat-c. Now we see which accounts are logged into the system. We will use psLoggedOn, which shows us local and remote logins, like so. Are there any active sessions that seem unusual, especially remote sessions? Now we view the routing table. If an attacker is using the machine to perform sniffing or evade network security, the routing table may have been altered. We use the command netstat-rn. Now we list running processes. We use the tool pslist, like so. If pslist isn't an option, tasklist is a similar tool that's built into Windows. Now we list running services. We use the tool psservice, like so. Services that are not Microsoft services or not related to known installed software might be suspicious. We could also use the command tasklist/svc, which shows running services with process IDs. Now we view any scheduled tasks using schtasks.exe, like so. We're checking because an attacker could use a scheduled task to maintain a backdoor. Now we list open files and the processes using them. This can be done with psfile, like so. Seeing open files might provide additional insight into what is taking place on the system. Finally, we can capture memory dumps for processes we believe may be of interest. The tool procdump from sysinternals provides several useful options. Here we list its usage options, which you can explore later. For now, we will perform procdump-MA and a process name. As we collect data onto our forensics workstation, we might find traces of problems here and there. We want to correlate systems changes, processes, user sessions, file activity, and network activity to build a picture of what is taking place. In your live responses, if you need to use the data you collect as evidence, be sure to take hashes of each of your files. Good luck!